Hi everyone. Today we are going over section 2.6, which is on decomposing cubics. Now we did cover this in 2 days in class. I am going to do both days in one video. Okay, so if you need the first day, it's the first half, and the second half will be the second day. All right, so the first thing we are going to start with are zeros. Zeros are just another word for x-intercepts. Now, you will hear me and see it going back and forth between zeros and x-intercepts or roots. Okay, so that's another name for zeros. So we can go back and forth between any three of these. Now, zeros can be identified on a graph. Okay, so if you remember, x-intercepts are points where a graph or where a line crosses the x-axis. Okay, so that is what you're looking for. Where does it cross the x-axis? And last but not least, we are going to write these zeros as coordinates. Right? X, comma, 0. Okay, so I'm going to give you a couple examples, a couple graphs or different graphs, and all we're going to do is identify the zeros. Okay, so I can draw a graph. Something that looks like this. Now, this isn't a cubic. This is a polynomial to the 4th degree, but all we need is to figure out where this line, where this graph crosses the x-axis and what coordinates those are. Okay, so starting at the left, I am at -3, 0. Next one is at -1, 0. Third one is at 2, 0. And then the last one is at 5, 0. So my zeros are these four. That's it. That's all you need to do. Okay, so let me give you another graph here. Okay, now these aren't going to be perfect, but let's say it crosses here, here, and here. Okay, again, my zeros are -2, 0, 3, 0, and 7, 0. And that is my answer. That's it. Okay, this is probably the easiest part out of this section, is to identify the zeros given a graph. Okay, but sometimes you will have to sketch a graph of any given function. Okay, so now you're working backwards. I'm giving you a function. So for example, I want you to sketch a graph of f of x is equal to x plus 2 times x minus 7 times x minus 4. Okay, so we need to use that function to figure out the zeros. Okay, so the first thing we're going to do is to identify those zeros. Identify or solve for the zeros. Okay, now on here you can see that you have 3 parentheses. Okay, so that means that I can split these parentheses individually and set their own equation to them. Okay, now if you remember the zero product property that we used in our first unit, that's exactly what we're going to do. Okay, so we are going to set each parentheses equal to 0. Okay, so the first one would be x plus 2 equal to 0. And I have x minus 7 is equal to 0. And x minus 4 equal to 0. Okay, so solving these will give me my zeros that I will need to sketch a graph. So for the first one, I'm going to subtract 2 to both sides. X is equal to -2. So my first coordinate would be -2, 0. That's one of the zeros. Second one, I add 7 to both sides. X is equal to 7. So my coordinate is 7, 0. And last but not least, I add 4 to both sides. X is equal to 4. My coordinate is 4, 0. Okay, so now I am going to use these zeros to sketch my graph. Okay, so I'm going to go ahead and draw a graph. Again, it doesn't have to be perfect. It is a sketch, right? I know I'm going from -2 to a 7, so just make sure we have enough room for that. Again, we're only going to focus on x-intercepts today. I'm not too concerned about y-intercepts. Okay, so my first point was at -2, 0, which is here, -7, 0, and 4, 0. Okay, so now I'm going to go ahead and draw a graph. Now this has 3 parentheses, so this is a cubic function. So it's going to look something like that. Again, it's not perfect, but it is going to look something like that. And we're done. That is a sketch of a graph of f of x is equal to x plus 2 times x minus 7 times x minus 4. Okay, for our next example, I want you guys to sketch the graph of f of x is equal to x minus 1 times x plus 2 times 2x minus 3. So go ahead and pause this video, and I want you to go ahead and try this, okay? So you identify or solve for the zeros, and then try to sketch your graph. Okay, so I'm going to identify my zeros. I have 3 parentheses, so I'm going to have 3 different equations equal to 0. I have x minus 1 equal to 0, x plus 2 equal to 0, and 2x minus 3 is equal to 0. So in the first equation, x is equal to 1. My coordinate is 1, 0. Second equation, x is equal to -2. So my coordinate is -2, 0. And my third equation, now this is a little different than what we've been doing, right? This is a 2-step equation instead of a 1-step, but it's still the same process. Add 3 to both sides. I get 2x is equal to 3. Divide both sides by 2. X is equal to 3 over 2, or 1.5 if you want to turn it into a decimal, because it is easier to graph when it is a decimal. It's easier to see. So I'm actually going to use a decimal, so it's easier for me to graph. So 1.50 is my other coordinate. Okay, so these are the 3 coordinates that I am going to sketch a graph for. Okay, so here's my graph. Again, it is not going to be perfect. Okay, so I know that I have points at 1, 0, -2, 0, and 1.50, which is right between 1 and 2. And then go ahead and draw your cubic. And I'm done. Okay, so this was the end of day 1. We did some practice to go along with this. So if you were here for the first day but not for the second, the next part will be the second. If you weren't here for the first, or you were only here for the second day and not the first, then you can stop here. Okay, so the second day we started with multiplicity. Okay, so multiplicity sounds like multiple, and that's exactly what it is. The multiplicity is the multiple of the same 0. Okay, so you will have multiples of zeros. Okay, so when you are looking for multiplicity in a function, you are going to look for the exponents that they give you. Okay, so we're going to do a couple examples that where we have to find the multiplicity. Okay, so example 1, we're going to determine the zeros and the multiplicity of f of x is equal to x plus 2 to the 3rd power times 2x minus 1. Now you need to find the zeros, and which is what we just did. Okay, so you need to identify those zeros and then find the multiplicity. So the first step to this is actually the first step to finding zeros when we're graphing. So I'm going to identify my zeros. And it is the same step that we did before. Okay, so here I see two parentheses, right? So I'm going to set those functions equal to 0 and solve separately. Okay, so that step is the same. So I have x plus 2 equal to 0, and 2x minus 1 is equal to 0. Subtract 2, x is equal to negative 2, so my coordinate is negative 2, 0. Same as before. The other equation, I have 2x is equal to 1, divide by 2 to both sides, x is equal to 1/2, which means that my coordinate is 1/2, 0, or 0.50. Okay, I'm not asking you to graph, so a fraction is fine. If you want to change it to a decimal, you can. Okay, now instead of graphing, I am going to look for the multiplicity. Okay, so now I'm going to look at the exponents. Okay, so the function is x plus 2 to the third power and 2x minus 1. Okay, so I'm going to separate those again. So I have x plus 2 to the third power and 2x minus 1. And what I am looking at here is at the exponents. Okay, so my exponent for my first function, or the first part of my function of x plus 2 is 3. So that means that at negative 2, 0, because that was my 0 at that with that equation, it has multiplicity of 3, because 3 is the exponent with that part of the function. Now, 2x minus 1, I wrote a 1 there because it didn't have anything. Okay, so if it doesn't have an exponent, it's not 0, or else you wouldn't have that part of the function at all. It's actually 1. Okay, so feel free to draw or write that 1 in so that you can visualize what that exponent's going to be. So same as before, at my 0 at 2x minus 1, we just solved, was 1/2, 0. So it has a multiplicity of 1. So my final answer is that at negative 2, 0, it has multiplicity of 3. At 1/2, 0, it has multiplicity of 1. And that's it. So instead of graphing it now, we are actually looking for the multiplicity and the zeros. Okay, so let's go ahead and do this again. You can go ahead and try example number 2, which is determine the zeros and the multiplicity of f of x is equal to x minus 5 times x plus 3 times x plus 3. Okay, so go ahead and pause this video if you want to go ahead and try that. Now this one, there's something going on in this function. And if you haven't noticed already, you have two of the same thing in two parentheses, right? You have x plus 3 and x plus 3. So I can rewrite this function. Okay, this can be rewritten as f of x equal to x minus 5 times x plus 3 squared, because there's two x plus 3's that you're multiplying with. So that's exactly what I'm going to do, because it's going to be easier for me to see the multiplicity. First step again is to identify the zeros. My zeros here are x minus 5 equal to 0 and x plus 3 equal to 0. Okay, so I'm not going to solve this, but x is equal to 5. So that means that your coordinate would be 5, 0. X will equal to negative 3 here. So your coordinate would be negative 3, 0. Okay, so then I'm going to go ahead and look at my exponents. Okay, so I have x minus 5 and x plus 3 squared. So this has an exponent of 1 if they don't write one. So at 5, 0 has a multiplicity of 1. At negative 3, 0, it has a multiplicity of 2. And that's it. These two are my answers. Ooh. And I'm done. Now, combining functions. Okay, sometimes when you're given two or more functions, you can combine them by adding, subtracting, multiplying, or dividing. Okay, we are going to focus on adding, subtracting, and multiplying. Okay, dividing functions or two or more functions is called synthetic division, and we're not going to cover that in this unit. Okay, so I'm going to give you an example. Given that f of x is equal to x to the third power minus 16, and g of x is equal to x to the third minus x plus 17. I want you to find f of x plus g of x and simplify that. Okay, so what I'm going to do is I'm going to write the two functions, whatever they're equal to, and add them. So I have x to the third minus 16 plus x to the third minus x plus 7. Now, because I am adding two functions, there really isn't a need for these parentheses. All you really have to do here is to combine your like terms to simplify. So that's what I'm going to do. X to the third plus x to the third will give me 2x to the third. A negative x, I have nothing else to combine it with, so I'm rewriting it. And then negative 16 and a positive 7 will give me a negative 9. So this is my final answer when I add f of x with g of x. That's it. Okay, now they will get harder as we go. Okay, so now we're going to use the same functions and we are going to subtract them. Okay, now subtraction has an extra step here. Okay, so my extra step, because I'm subtracting a whole function, I need to get rid of the subtraction signs. Okay, and to do that, I am going to use KFC. Okay, no, not the chicken place. Keep, flip, change. Or keep, change, change, some teachers may have used. Okay, what that means is that I am going to change this function or manipulate it a little bit so it's easier for me to combine like terms later. The first part is going to stay the same. That's my keep part. I'm going to flip that minus to a plus, and I'm going to change that second function to the opposite. Okay, so this will become x to the third minus 16, that stay the same, plus this x to the third will become negative x to the third. This minus x will become a plus x, and this plus 7 will become a minus 7. Now all you need to do is combine your like terms like we did above. Okay, so my like terms here, x to the third and negative x to the third will actually cancel out. You get 0. This x, you cannot combine it with anything, so I have x by itself. Then negative 16 and negative 7 will give you negative 23. And I'm done. Okay, so that was subtraction. The last one that we're going to focus on is multiplying these functions. And this is where it gets a little messy, or could get a little messy. Okay, so make sure that you try to stay as organized as possible. So I'm going to go ahead and rewrite my functions. And now we are multiplying these together. Okay, again, I'm going to try to stay as organized as I can. So I need to distribute here. I need to distribute both of these terms, so I need to distribute the x to the third, and then I need to distribute the negative 16 to everything in the other parentheses. Okay, so x to the third times x to the third will give me x to the 6. Right, I have 3 in the first one, 3 in the second one will add up to give me 6. X to the third times a negative x. Well, how many x's do I have in total now? I have negative x to the fourth. X to the third times 7 will give me a positive 7x to the third. Now the next term, that negative 16 times x to the third, will give me a negative 16x to the third. Negative 16 times a negative x will give me a positive 16x. And negative 16 times a positive 7 will give me a negative 112. Now you want to combine your like terms. Okay? With the x to the 6, I don't have any other term with x to the 6. So I am just rewriting that. Same thing with minus x to the fourth. I don't have anything to combine that with, but I could combine the x to the thirds. I have a positive 7x to the third minus 16x to the third, which will give me a minus 9x to the third. 16x is by itself, so I rewrite it. And the negative 112 is by itself, so I rewrite it. And now I am done.